If they're going to hit us.
Exactly.
With ample time to kiss your goodbye.
One of the most exciting times for astronomy, because basically this thing got discovered and it was also moving super fast.
Right.
So it was only observable for a couple of weeks from ground-based telescopes, and then upwards of 3 or 4 weeks.
Would you expect it to be moving fast if it's coming in from interstellar space?
Yes, you would expect it to be moving fast.
And why would it be faster than anything else?
Because the planets are all moving in the same direction around the sun. Oumuamua comes in and it's coming from a totally different direction, and then it looks like it's moving really fast compared to our motion.
We found this thing.
Yes.
Called it Oumuamua, which sounds Hawaiian.
It
Yes,
does.
it is
I
Hawaiian.
think was it discovered by a telescope in Hawaii?
So it was picked up by Pan-STARRS, which is a telescope in Hawaii that is funded by the Department of Defense, and they're looking for near-Earth objects.
Okay.
So small kilometer-scale objects. So some of those objects are potentially hazardous. So it's very important that we find them with ample time to do something if
they're going to hit us.
Exactly.
With ample time to kiss your goodbye. You need enough time to get that out of the way. Well, so it seems to me, from what you say, Pan-STARRS had no expectation of finding interstellar objects, but it has the ability to do so regardless. Is that a fair statement?
Well, that is true, but I think they originally designed Pan-STARRS hoping to find interstellar objects. Because for the last couple of decades, I mean, we know the solar system has ejected a good amount of material in interstellar objects. So it's not much of a stretch to imagine that other planetary systems would also be ejecting material, and we would see them. And the only difference is you just see a small body, but it comes across the night sky and looks hyperbolic. But the fact that we hadn't seen any, we were trying to put limits on the number of them in the galaxy based on not seeing any. But the hope was that Pan-STARRS would find one.
Right. So if you don't see any for a certain amount of time, you can say there can't be more than this number, otherwise we would have seen it statistically.
Yes, that's exactly
Now, you
right.
said it was hyperbolic. Tell me what you mean there. Because some people are hyperbolic. You know, and
A different sense of the word hyperbolic.
Yes. No, so it's the Flavor Flav of comics. Just, we knew it was hyperbolic because it was like, yeah, boy.
So it came into the solar system and left, and it's never coming back, because hyperbolic means that its orbit is not bound to the sun.
So hyperbolic, so that would be the best evidence that it was not a member of the solar system. Because comets are coming in from out far away all the time.
That's right.
So why isn't it just an asteroid? Why do you know it's a comet?
So there is kind of a continuum between comets and asteroids.
Uh-oh, so now we get into word issues.
That's right.
Word definitions.
Uh-oh.
Yeah.
So the things that formed at large distances from the sun, they have ice in them.
Which hasn't evaporated away over the years. Eons, yeah.
Exactly. So when a comet gets close to the sun, the ice will heat up and sublimate, producing a dust tail. And that produces a bright, beautiful cometary tail.
You can't say evaporate.
Yeah, I can't.
Right, it sublimates.
You've
Yes.
got to use the real word.
Well, of course, yes.
You know, to regular folk, it's evaporating.
Yeah, exactly. But no.
Sublimates.
Yes.
Remind us what sublimate means.
So that is when the ice well, not just in a comet, but when ice transitions straight to the gas form.
Straight away, without melting in between.
We expected that the interstellar objects that get ejected from other planetary systems, that they most likely would have formed at large distances and then had a lot of ice in them. So we'd expect them to be comets.
Is that because if they form at a large distance, they're not strongly held by the gravity of their host star?
Yeah.
So they can be knocked off?
That's exactly right.
Okay.
And if they form at far distances, then they haven't been close enough to their host stars for the ice.
Yeah, so you get a double force going there. With the hydrogen and oxygen and comets and all of this, does this affect anybody's sense of where the water on Earth came from?
Right. Yeah, so this is also kind of based on this student who's been working with me who's just started this last year.
You just got out of graduate school, and you got students already?
Good for you, man. I love it.
Man.
So that's Astor Taylor, who had a paper published that discussed the possibility that the dark comets could have brought water to the Earth. So,
more so than other comets?
All right.
Well, so people used to think that comets delivered water to the Earth, and we still don't know where the Earth's oceans came from. And Part of the reason that we're now not sure if comets delivered the water is because we have spacecraft measurements of water in comets, like the Rosetta mission went to 67P, and some of the isotopes, which is some of the things about the water in that comet, did not match that we've measured in the Earth's oceans.
This would be deuterium, I
yes,
guess, right?
yes. So that's one of them. So the deuterium to hydrogen ratio.
Yeah. So hydrogen is just one proton in the nucleus, and the protons define what we label the element to be. So now you throw in a neutron.
Okay.
It's still hydrogen, but now it's like a little heavier.
Right. So you can't just, it's got to be hydrogen, something else.
Something, you got to do
you
something,
need something
with the name. Right. And so we call it
can't.
deuterium.
Right.
How stable is deuterium?
Well, it's not that it's stable. It's just the important thing is that the amount of deuterium compared to hydrogen isn't going to change from processing. And it depends very critically at the temperature of formation.
It won't change chemically.
Right.
So if the comet doesn't match that in the oceans, you can't credit the comet for delivering
That's
the
correct.
water.
So we don't know for sure, and Astor was very careful to say this in the press releases and news articles about their paper, but we can't say for sure that dark comets could have contributed water to the Earth, but they are a entirely new population of small bodies that are in a new source, potential source. They're in the vicinity of the Earth, and they potentially have volatiles. So we would need follow-up observations to figure out if they match up. But the Hayabusa 2 mission, the JAXA Space Agency mission.
JAXA, Japanese Exploration Agency? Something
Yeah, it's basically Japanese NASA. But their Hayabusa 2 mission.
What's JAXA?
It just
not NASA, but JAXA.
I'm sorry, that just sounds very racist.
NASA came first, dude.
This is true.
America.
Okay. Listen, I don't have a problem with it.
So their Hayabusa 2 mission, in the extended mission, it just so happens is going to a dark comet.
Cool.
So in 2031, we're going to have...
That'll blow it open.
Yeah.
It might... Well, it's at least going to rendezvous with it. But we'll have enough sensitivity to measure things like outgassing or dust if it's there. So at the very least, the worst case scenario, we're going to have an answer to all of this in 2031.
Now, literally, comets are dark, even when they don't satisfy your definition. Right. We think of them as these white things moving through space, but their material is very dirty on a level. How reflective is a comet?
Well, it's difficult to say because you don't always see, most of the time you don't even detect the nucleus or the rocky part of the comet. You just see the tail. Okay. But asteroids, for example, like asteroids typically have albedo is the word we use in science, but that's how reflective they are. So albedo is between something like 0.04 to 0.1, which is like 10-ish%.
That's black.
Yes.
That's black.
Okay.
Yeah, albedo from between 0 and 1. If it's 1, it's like a mirror.
Right.
If I remember, the moon is about 7% albedo.
Okay.
And what is Pluto?
So there are parts of Pluto, like there's a glacier of nitrogen, or nitrogen ice actually, and that has an albedo upwards of like 90%. So it's very reflective.
So it'd be a bright spot if you look at it.
I read an article once that was talking about another reason why Pluto isn't a planet is because it reflects so much that it makes it look much bigger than it actually is.
Well, initially, I think that would have thrown off our measurements.
Right.
But now we got up and close and personal.
Yeah, well, now, we've been there now.
We've been there
now. So,
been there, done that.
Yeah.
So what's in the future of what you're up to?
So the Rubin Observatory is the most exciting thing, but it should be finding, upwards of tens per year interstellar objects.
Yeah, but this will be serendipitous. You can't say, go look at this object or look here and discover an object. You're waiting for the data to come to you.
Through you or to you.
But also, Rubin should better characterize the orbits of all of the known small bodies in the solar system and find a bunch of much smaller ones. So given that we have kind of just hit the tip of the iceberg in terms of finding these dark comets, I would bet that we're going to find many, many more dark comets in subtle non-gravitational accelerations. Right. So that could kind of revolutionize how we think of even comets and asteroids.
All right, cool.
Wow. Look at you.